Hi, my name is Michelle Mitchell and I'm going to be teaching you a lesson on thermochemistry. So let's start out with the definition of thermochemistry. So thermochemistry is defined as the branch of chemistry that is concerned with the quantity of heat that is absorbed or evolved in a chemical equation. So let's get down to business. So there is one master equation in all of thermochemistry, and it can be derived and changed into other equations in other thermochemistry problems. So the master thermochemistry equation, as you could call it, is Q equals mc triangle T. Don't get the triangle confused for an A. It's not an A, it's a triangle. Think Illuminati. So now it's time to find out what these letters mean. So these variables are important and can be found in the problem, and you're going to need these to use your equation. So m is equal to mass, and the mass is the weight of the liquid. Q is equal to energy in joules. Joules is the common measurable factor for energy. Triangle T is used to represent temperature change. The temperature change will usually be stated, and it will ask to be subtracted. C is equal to specific heat. Usually specific heat is given, or you have to know it yourself. So let's look at this problem. How much heat is needed to raise the temperature of 50 grams of water from 18 degrees Celsius to 30 degrees Celsius? Specific heat of water is 4.18 joules over grams Celsius. So let's start out by finding what the variables that we have. So we know we have mass because it's 50 grams, and grams is a unit of mass. 18 degrees Celsius to 30 degrees Celsius is a temperature change. Remember when I said they'll ask you to subtract it? This is when you're going to subtract it. So now that we know all the things, let's solve it. So we have the equation Q, which is what we don't have, so that's what we're trying to solve for, equals mc, m being 50, times c, which is 4.18 because that's a specific heat, times temperature change. So you're going to subtract 30 degrees Celsius from 18 degrees Celsius, and you're going to get 12, and then you're going to multiply. Once you multiply it all together, that's your answer. Excuse me for a minute while I calculate that. So Q is equal to 2,508 joules, and that's it. So you need 2,508 joules to heat up a 50 gram amount of water from 18 degrees Celsius to 30 degrees Celsius. But what if you're not looking for Q? Don't panic, it's easier than you think. So let's say we already have Q in the problem that we're given. So we need to find something else. So let's try to find M. So what you're going to do is you're going to take that master equation, Q equals mc triangle T. That's the first step. The second step that you're going to do is you're going to divide both sides to isolate the variable, just like in algebra. And I know we all hate algebra, but this is chemistry and it should be easy. So you just divide both sides to isolate the variable. We're isolating mass because that's what we're looking for. So we're going to divide by C triangle T on both sides. So M is equal to Q divided by C triangle T. And that's how you find mass. It's that easy. It's the same for every single one. So let's say that you're going to find a different variable. Let's try to find triangle T. So you're going to take that master equation again. Q equals mc triangle T. You're going to divide it by mc. Divided by mc, Q equals triangle T. triangle T equals Q over MC. Or you can do another one, C equals Q over M triangle T. It's that simple. So let's use another equation. Heat energy of 645 joules is applied to 188.4 grams of glass. Its temperature increases negative 11.6 degrees Celsius to 15.5 degrees Celsius. What is specific heat? So C is equal to specific heat. So we're just going to take 645 joules and we're going to put it over 28.4 and multiply that by the temperature increase, which should be around 27. And the answer is going to be 0.84. So let's do one last problem. What is the mass of copper that increases the temperature by 285 Celsius when 186,000 joules of energy is applied? Copper has a specific heat of 0.387. So we're just going to use the equation to find the mass, plug in the variables and put them on top of each other. And we're going to multiply the bottom half together. We're going to divide it all together. And we're going to get 1686.4 grams. And that's the mass. So that's it for thermochemistry. Now you're a pro. So thanks for watching my part, and I hope that you learned a little bit more about thermochemistry if you weren't a pro already.
Okay, hello guys, this is Alan. I'm going to be teaching you how to do stoichiometry, which is honestly my least favorite thing to do. Hated stoichiometry. Maybe because I suck at that. Okay, so first I'm going to tell you what stoichiometry is. Stoichiometry is basically just a bunch of math, and it's really easy once you learn how to do the mole island. And the definition of stoichiometry is a section of chemistry that involves using relationships between products and or reactants. And you have to make sure that when you're using your chemical equation, you have to make sure the equations are balanced, or else it's not going to work. Okay, now I'm going to teach you how to do the mole island, which is going to be your favorite thing in stoichiometry because it's going to help you so much. It's literally the best. Okay, so on top left you can see it's mass, which is in grams. In the middle it's volume, which is in liters. Bottom left, which is particles, which is in atoms. In the middle it's going to be your moles. It's going to help you because it's going to teach you how to go from mass to moles, from volume to moles, from particle to moles, and vice versa. And then it's teach you how to go from like element to element, because it's like transferring moles to moles and everything. And on the right, it's going to be the same thing. Okay, so 1 mole is equal to the molar mass, which is in grams. And then 1 mole is also equal to 22.4 liters. And then 1 mole is equal to 6.02 times 10 to the 23rd power. It's also going to be the same on this side. Nothing changes. So it's 1 mole is equal to the molar mass, which is in grams. And then 1 mole is equal to 2.4 liters. 1 mole equals 6.02 times 10 to the 23rd particle. You're going to want to know this mole island by heart if you really want to do good in stoichiometry. It's going to help you out a lot. Okay, now we're going to do an example of a stoichiometry problem. Remember I told you always make sure your chemical equations are balanced or else you're not going to be able to do it. So that's what we're doing here. Now this question is asking how many moles chlorine will react with 4.55 moles of carbon. So you put 4.55 moles of carbon because that's what you're trying to figure out what will react, and it's going to turn into chlorine. And right on the top left you see it's 4 moles of chlorine. And you know you have 3 moles of carbon. So it's literally all you do. It's so easy. And that's where I got the 4, and that's where I got the 3. And you're done.